Welcome to all. My name is Dr. P.R. Krishnaveni. Today's lecture is on problems on combustion. Combustion. Combustion is an exothermic chemical reaction accompanied by liberation of heat. While doing problems on combustion, we have to remember few points. First, convert the percentage composition into actual composition. Weight of oxygen should be calculated. Weight of oxygen should be converted into volume of oxygen. Weight of air required, then volume of air required must be calculated. So, as we have said, combustion is an exothermic reaction accompanied by liberation of heat. So, carbon on burning in presence of oxygen gives rise to carbon dioxide plus 97 kilocalories of heat will be released. So, while doing problems on combustion, the amount of carbon, hydrogen, sulfur, carbon monoxide and other hydrocarbons, they should be considered for complete combustion in excess of air. So, products of combustion by volume and then percentage composition by volume must be calculated. Next, important formulas that we have to remember while doing problems on combustion. 1 gram mole of any substance occupies a volume of 22.4 liters. 100 parts by weight of air contains 23 parts of oxygen. 100 parts by volume of air contains 21 parts by volume of oxygen and 79 parts of nitrogen. Now we will practice problems on combustion. So, the problem given to you is calculate weight and volume of air required for complete combustion of 1 kg of carbon. So, coming to the solution, first weight of carbon in fuel. It is given as 1 kg. That means, next combustion reaction means carbon in burning in presence of oxygen gives rise to CO2 plus 97 kilocalories of heat will be released. So, carbon means atomic weight 12, oxygen 32. This will give rise to 44. So, this is the heat released. Now, 12 kgs of carbon requires 32 kg of oxygen for combustion. Now we have to calculate 1 kg of carbon requires how many kgs of oxygen for combustion. So, weight of oxygen required for combustion will be equal to 32 into 1 by 12. This will be equal to 2.67 kgs. This will be equal to 2670 grams. Now, this is the weight of oxygen. Next, volume of oxygen. So earlier I showed you the formulas for this. So volume of oxygen, how we can get means, volume of oxygen required, we will be calculating basing on 1 gram mole of oxygen at NTP, normal temperature and pressure, occupies a volume of 22.4 liters. So this is the point what I have showed you earlier. Now 32 grams of oxygen occupies 22.4 liters of volume. So now we have to find for 2670 grams of oxygen. So 2670 grams of oxygen occupies how much? So volume of oxygen required for combustion will be equal to 22.4 into 2670 by 32. This will be equal to 1869 liters. Next, volume of air required. Volume of air required. How we will calculate means the second formula we have discussed now. 100 parts by weight of air contains 23 parts by weight of oxygen. That means 100 grams by weight of air contain 23 parts by weight of oxygen. Now, how many grams by weight of air contains 2670 parts of oxygen? So, weight of air required for combustion will be equal to 2670 into 100 by 23. This will be equal to 11,607.5 grams. This will be almost equal to 11.7 kgs. Next, volume of air required. Sorry, this is the weight of air required. We are calculating in grams now, so that is the weight of air required, and this is the volume of air required. So for volume of air required, 100 parts by volume of air contains 21 parts by volume of water, sorry, by volume of oxygen. That means 100 liters of air contains 21 liters of oxygen. Now, how many liters of air contains 1869 liters of oxygen? So, from this, volume of air required for combustion will be equal to 1869 into 100 by 21. This will be equal to 8900 liters. So the question asked for us is calculate the weight and volume of air required for complete combustion of 1 kg of carbon. So weight of air required for complete combustion of 1 kg of carbon is 11.7 kgs and volume of air required for complete combustion is 8900 liters. So this is how we will be calculating. So coming to the next problem. A sample of fuel contains the following by weight: carbon 81%, hydrogen 4%, oxygen 2%, nitrogen 10%, sulfur 1%, the remainder ash. Calculate the volume of air required for perfect combustion of 1 kg of fuel assuming STP conditions. So for this, first we will draw a tabular form like this. So starting we will take percentage of composition present in the fuel. Next one, actual composition in 1 kg of fuel. Actual composition in 1 kg of fuel. Next, combustion reaction. Next, weight of oxygen required for combustion. So the first composition given is carbon 81%. So first one given is carbon 81%. So coming to actual composition in 1 kg of fuel, it will be 0.81 kgs. Coming to the combustion reaction, C plus O2 gives rise to CO2. That means this is 12, 32, 44 plus heat will be released. So volume of oxygen required for combustion will be 0.81 into 32 by 12 is equal to 2.16 kgs. This is 16. Next one given is hydrogen 4%. So actual composition in 1 kg of fuel 0.04 kgs. So coming to the combustion reaction, H2 plus half O2 gives rise to H2O. 2 plus 16 gives rise to 32. So coming to the weight of oxygen required for combustion, 0.04 into 16 by 2, that is 0.32 kgs. Next one given is oxygen 2%. So coming to the actual composition in 1 kg of fuel, it will be 0.02 kgs. But oxygen present in the fuel will be existing in combination with hydrogen as H2O. So that's why it should be subtracted from the weight of oxygen required. So that's why it will be minus 0.02 kgs. By means here oxygen present must be subtracted. Next composition given to you is nitrogen 10%. So coming to the actual composition 1 kg of fuel, it is 0.10 kgs, and here we won't write the combustion reaction. Why? Means nitrogen is a non-combustible gas. This is a non-combustible gas. So this won't contribute to the calorific value. Next, sulfur. Sulfur 1%. So coming to the actual composition 1 kg of fuel, it is 0.01 kgs, and the combustion reaction is S plus O2 gives rise to SO2 32, oxygen 32 gives rise to 64. So weight of oxygen required for combustion, this is 0.01 into 32 by 32. This will be equal to 0.01 kgs. So now total weight of oxygen required for combustion. So total weight of oxygen required for combustion, this will be equal to the total of all these, that is 2.47 this is 0.01 1047 kgs. Now volume of oxygen required, volume of oxygen required. Volume of oxygen required will be 32 grams of oxygen at STP occupies a volume of 22.4 liters. Now 2470 grams of oxygen at STP occupies how much? So this will be equal to 2470 into 22.4 by 32. So this will be equal to 1729 liters. Next, weight of oxygen required. Weight of oxygen required for combustion. So as already we had discussed, 100 kg of air contains 23 kg of oxygen. Now, how many kgs of air contains 2.47 kg of oxygen? So now, from weight of oxygen required for combustion will be equal to 2.47 into 100 by 23 is equal to 10.74 kgs. Now, volume of air required for combustion. Hundred liters of air contains 21 liters of oxygen. Now, how many liters of air contains 1729 liters of oxygen? This will be equal to 1729 into 100 by 21. This will be equal to 8233.3 liters. So the volume of air required for complete combustion of 1 kg is 8233.3 liters of oxygen. So like this we can practice problems. In the next video, we will discuss about rocket fuels. Thank you.